Okay, we are very grateful for this last plenary lecture from Dr. Francesco Caselli, as you all know. It's always lectures before lunch are more conducive to a lot of attention, because we are having this for one hour, and perhaps some questions and discussions can follow. Okay.
Right.
From LSE.
So thank you, Angel, for having me for this, and thank you everybody for sticking around so late in the conference for this talk. If a country finds a new oil field, or if I find a gold mine or a copper deposit, is that great news, or is that a bit scary? Or similarly, if a country is already producing oil or gold or copper, and the price of oil goes up, or gold, does that mean that this country now has finally the resources to invest and grow? Or does it mean that this windfall from the resources will start distorting the economy or perhaps the political system in ways that actually makes things harder for this country to grow than otherwise? These are questions that have been around for quite a while. Economists have been worried about this at least since they started thinking about Dutch disease in the 60s and 70s, and probably even earlier. But that question is sort of a renewed interest and renewed force in the last several years. First, because there are lots of countries, particularly poor countries, that keep discovering more and more oil and other natural resources. And so there are this thought experiment, you find oil, is that good or bad? It's almost every day there is a new country that has to ask that question. And also, of course, the prices of primary commodities have been very high lately, also generating lots of resource windfalls for many countries. So these are very important questions for many countries right now. Now, up to fairly recently, at the cost of a massive oversimplification, what did we have to go on to answer this question? Well, basically, and I'm simplifying, we had country case studies, and we had cross-sectional, cross-country correlations. Okay? By and large, that's what we had until very recently. And that's okay, but of course, it only helps you up to a point. Case studies are useful, they generate ideas, but of course, for any countries that look like they got completely destroyed by finding oil, you can find other countries that seem to have actually benefited from the oil. So it is not that conclusive. And of course, cross-country correlations, they've been very important, very influential, very useful. But again, you worry about the usual things that economists worry about, which is reverse causation, which is omitted variables, spurious correlation, and so forth and so forth. Now, over the last few years, there has been a new body of work that I think could be thought about as phase 3 in research on this topic. So phase 1 is case studies, phase 2 is cross-country correlations, phase 3 is studies that try to get at the causal mechanism, try to attack the causal mechanism from resource windfalls and outcomes. Having said that, I'm not going to give you an overview of this recent literature. I will try to give you a flavor of some of this work that I have done, not necessarily the best work in this area. Other people probably are doing much better work. But I give you 2 examples in my talk of this phase 3 stage of research on resource windfalls that tries to find ways of saying something about causal mechanisms as opposed to just correlations. Now, the 2 examples I give you are in many ways very different. First, I'm going to look at 2 very different outcomes. One outcome is violence, specifically international violence, cross-country conflict between 2 countries. And the other outcome I look at in the second study I'll talk about is corruption. So quite different outcomes. And the setting will also be quite different. One is going to be, by construction, sort of a large panel of countries. The other will be within country variation, particularly in Brazil. So very different settings, but they will have one thing in common, that both studies will try to overcome the identification issue of causal mechanisms by exploiting the spatial distribution of the natural resources. In both cases, I will be relying heavily on information on the spatial distribution of natural resources to try to devise strategies to get a causal mechanism. So that's going to be the unifying themes. And again, the two papers I talk about are not the only ones in the literature that use the spatial distribution of natural resources for getting a causation. So this is representative of work by others as well. Okay, let me begin with the first of the topics, which is conflict. This is based on a paper with Massimo Morelli and Dominic Rohner. So a lot of international relations scholars, political scientists, have argued that in many cases, natural resources are a severe risk factor for cross-country conflict. Basically, countries fight over natural resources. Country A sees the oil in country B, they go for it. And that, in the estimation of many people who have looked at specific cases, is a serious, a systematic source of conflict. So this study is an attempt to provide some causal evidence for this mechanism. Now, the first thing you might try to think about when you think about how you're going to test for this story is to say, for example, something like, let's take a sample of country pairs, perhaps contiguous countries, and look at how the presence of oil in one of the two countries or in both predict conflict compared to a situation where oil is not present. You can immediately see that this strategy would have all the pitfalls of what they call phase two, or cross-country correlations. Okay, so for example, one problem could be that it just happens that in some regions of the world where oil happens to be abundant, there are also other mechanisms that happen to be present in that region that make countries fight with each other. Think about the Middle East. So in the Middle East, there is oil, there is a lot of conflict. Can you say they are fighting over the oil? So that's problem number one. Problem number two with this simpler approach would be that it wouldn't tell you that much about the mechanism through which the presence of oil causes countries to fight. It wouldn't necessarily tell you that they're fighting over the oil. So for example, it could be that one country finding oil changes the political system in that country in a way that makes that country more prone to attack other countries, or more vulnerable to attack from other countries. Or it could just be that having the oil make one country more able to pay for a big army and go for other countries. Okay? So that's not what I'm trying to do. Here is the idea I'm going to pursue here. Suppose it is true. Oh, and by the way, sorry, I already switched from resources to oil without comment. Let me just say why, because there's two studies that we'll focus on are about oil. The data we have are about oil. We are hoping, of course, to make points that apply more broadly, but the kind of data we have are about oil. So here is an idea. Suppose it is true that countries fight over the oil. In particular, I see Angel has oil, and I want to capture his oil. Well, if that's true, it should matter a lot to me where is that oil. Where in Angel's territory is the oil? If the oil is really close to the border, what am I looking at? I'm looking at a local conflict. I'm possibly looking at a local population who is sympathetic to me. I'm looking at just carving out a small enclave in Angel's territory, which I can probably supply fairly easily and defend fairly easily. Now suppose instead that the oil is far away from my border, deep into Angel's territory. Well, now I'm looking at a much more difficult proposition. I'm looking at winning a whole bunch of battles on my way to the oil. I'm looking at very stretched supply lines for my army. I'm looking at a local population who is probably getting more and more hostile as I drive into the country. I look at an international community who will probably give me a harder time if I take half of his country as opposed to just a little possibly disputed border area. And so I should be much less willing and much less prone to go after this. Okay, so that's going to be the idea I'm going to try to exploit. If it is true that they fight over the ore, it should matter where the oil is. Now, as a very first, not test, this is not a test, but as a very first overview of the data, just to get a sense whether this is likely to lead me anywhere, look at this picture. So in this picture, every dot is a country pair. And a country pair has to satisfy two requirements to make it into this picture. One requirement is that they need to be contiguous. And by contiguous, I mean the following. They're either sharing a terrestrial border, or they are separated by less than 400 miles of water. Okay, so they're basically contiguous. And the second criterion for appearing there is that at least one of the two countries in the pair has to have oil. Okay? And then, given my sample, I'm going to measure this. I'm going to take, for each country pair, I'm going to look at where the oil is. All the oil fields in this pair. Could be many oil fields, could be just one, doesn't matter. It's going to be all the oil fields. I'm going to compute the distance from the border, from the bilateral border, of each of the oil fields in the pair. And then I'm going to take the shortest distance among all the oil fields. So I'm going to measure the distance of the closest oil field to the borders. I'm plotting that on the horizontal axis. What's the vertical axis? So I have a, oops, it's a bit cut from the top, but doesn't matter, the message comes through. I have a panel from 1946 to 2004 for this pair of countries. And I'm going to measure what fractions of the years these countries are in military conflict with each other. And what the picture tells you is that there is a massive negative correlation between conflict and distance from the border. Now, this is not a test of the hypothesis. Why? Because this is phase 2, right? This is a correlation. This is a cross-sectional correlation. Okay, there could be factors that are omitting here that correlates with the oil being close to the border. And so the rest of the paper is to go beyond this correlation and trying to devise a more aggressive strategy for causal identification. Before I go to the more aggressive strategy for causal identification, I want to talk a little bit about a theoretical model that is in the paper. The reason for doing that is that this is not the regression I'm going to run. I'm going to have a much more nuanced series of theoretical predictions that descend from the basic intuition that the position of the oil should be. Okay? And so to motivate that empirical specification, I need to give you a very impressionistic and superficial sense of the model. Because of time constraints, I won't be able to give you much detail on how the model works and many of the considerably subtle issues that come up in solving it and complications. So I just want to tell you, give you a very impressionistic sense of the mechanics of the model. So the model is a model of territorial war. Now, to think about territorial war, you need to have a geography. And as a side, this is the first model that we know of in the literature of territorial war, i.e. a model with war with a geography. Okay? The geography, however, is going to be very simple. The world is not going to only be flat, it's actually going to be one-dimensional. It's going to be the real line. So the world is the real line, which is here. And in this world, there are going to be two countries, country A and country B. And there's going to be some border between the two countries. So a point on this, on the real line to the right of the border, think about the border being normalized at 0. So this is all the, oops, sorry. These are all the positive, numbers. A point on the, to the right of the border is a location in country B. A point to the left of the border is a location in country A. Now, I will give these countries, each of these countries, a choice to be peaceful towards the other or to attack the other, to declare war. And it's enough for one country to want to fight to have a war. So if country B says, let's have a war, you have a war. Not country A cannot say, no, I don't want to fight you. So one innovation of the paper is the way we conceptualize the notion of war. So a war in this model is going to be the drawing of a new border from some distribution. Okay, so there's over this real line, there's going to be some distribution, and that describes the probability distribution of locations of the new border. So basically, a war is like buying a ticket for a lottery. Country B decides to fight. What does it buy? It buys the chances that the new border will be, oops, sorry, I keep giving away the rest of the stock. The chances that the border will be to the left, for example. And if it is to the left, then you can say country B kind of won the war, and the more to the left it is, the bigger the victory of country B. Okay? Now, in the model, there's going to be some random reasons why countries want to fight. So it's not like that if there is no oil, they don't want to fight. There's going to be some baseline probability of conflict based on some random considerations that come up that would make one country want to fight. Okay? So there's going to be some baseline. But what the rest of the model does is say, how does the presence and location of oil change the probability of conflict compared to this benchmark where there is no oil? Okay? So the first experiment is just, let's say country A discovers oil. And country A discovers oil at some location in its territory. Okay? So this is, it's not like only country A discovers oil, it's at some location. Okay? Now, there are conflicting effects on the likelihood of conflict, so let me give you just the one that dominates. The one that dominates is, of course, that now country B says, well, before I had some kind of cost-benefit analysis of deciding whether to go to war with country A, well, the only way this has changed now is to make me more willing to attack. Why? Because now there is a chance that the border after the war will be to the left of the oil fields, i.e. that I will capture the oil fields. Okay, so country B becomes more aggressive, and the likelihood of conflict goes up. So prediction number one is that one country gets oil, more conflict. Now the next question is, how does this depend on the location in the territory of country A? Okay, and here, this is the second result of the theory. If I move the oil away from the border, I get less conflict. Why? Because the chances of capturing for country B becomes less, and so country B becomes less aggressive. So that's when one country gets the oil. Then, of course, you can ask the question, if you start out with country A having the oil, but then now also country B finds the oil? Well, you can see where this is going. When country A has the oil, and then country B also finds the oil, the likelihood of conflict will go down compared to that case. Why? Because now country B starts worrying that they may be losing the oil in case of conflict. Okay, there is a chance that the war will bring the border to the right of country B's oil, so they could lose it. So they still have the same incentive to fight, but now they are more fit. There is a chance that they lose the oil, so their incentive is weaker. It's still the case, it is importantly, and this is prediction number 3, I guess, it's still the case that you get more conflict when both countries have oil than when neither has. Because there is always one of the two countries that in expected value is a net winner in terms of capturing or losing the oil. So there is always one country that is more motivated to fight compared to the situation where neither country has oil. But compared to when only one country has oil, there is less conflict. Okay, now, for the same reason as before, this is a situation where country B is the typical aggressor. Why? Because country B is the country with the oil far away from the border. So they are the ones who are the expected winner in case of conflict. And so the most important consideration in determining whether moving around the oil reduces or increases the likelihood of conflict is what is the effect on the incentive to fight for the country whose oil is farther away from the border. So if you move country A's oil away from the border, you're going to get less conflict because country B's incentive to go after country A's oil diminish because the chances of getting the oil diminish. But on the other hand, if you move country B's oil away from the border, you get more conflict because country B becomes more bold. They are less scared, they're less concerned about losing the oil. Okay? So those are those are kind of what the theory delivers. There are complications, of course. The main complication is that you also need to keep track of the incentive of country A. And so you need to work out the net effects of these two effects. But I wanted to give you a sense of some of the key predictions. So now, I have a bunch of testable implications. I have 5 testable implications. I go over them again in a minute. And so I want to take them to the data. So my strategy is going to run this regression in that panel of country pairs I showed you at the beginning. Although now I'm also bringing back all the pairs without oil. Okay, to make the picture before, I dropped the countries without oil, now I bring them back. So I have all the pairs that are contiguous in the sense I discussed before. All the country pairs in the world that are contiguous. So the dependent variable is going to be a dummy variable for whether the country pair ij, countries I and j, experience a military conflict at time t. It's a 0-1 variable, so it's going to be basically a linear probability model, but in the paper, as you can imagine, we do robustness checks to logit and probit and other specifications, and the results are very robust. So it's going to be a regression to predict that whether country I and j fight at time t. And the first thing I'm going to put in there, I'm going to throw in there, I'm going to put in fixed effects. And this is critical. I'm going to put in fixed effects for country I, country j, and time t. Okay, so if there is a country that for some reason, they have some very warlike dictator who likes to go to war all the time, that's going to be picked up by the country fixed effects. If there is a period in world history that is particularly turbulent, that there's a lot of war, that's going to be picked up by the time effect, by the year effect. Then the next 4 lines are going to capture my 5 coefficients of interest, which correspond to my 5 testable implications. Okay, so the first one is a dummy variable which takes the value of 1 if and only if one country in the pair and only one country in the pair has oil. So this captures the situation where only one country has oil. Both is a dummy variable for the situation where both countries have oil. Okay, again, 0 and 1, both countries have oil. So I'm obviously, as you can see here, I'm like in the theory, I'm using the case where neither country has oil as my baseline. Then I'm going to include an interaction between the one country has oil dummy with the distance of the oil from the border. And that is the minimum distance in the country that has oil. So the country that has oil could have many oil fields, and we take the closest, and we measure how far it is from the border. And then we have 2 additional interactions. Let me see. So let me just show you here. So this is a situation where one country is closer to the border than the other. So this is min dist. Okay, this is the distance from the border for the country whose oil is closest to the border. And this is max dist, is the distance for the country whose oil is farther from the border. Okay? And so I'm going to have both times min dist and both times max dist. Then I'm going to have a bunch of controls, which I read to you in a second. And I'm going to have an error term, which is a cluster at the country pair level. Okay, very briefly, to remind, what are the predicted coefficient signs from the theory? Well, beta should be positive, because the theory says when one country has oil, you should see more conflict than when neither country has oil. Gamma should be positive, but it should be smaller than beta, because when both countries have oil, that's the intermediate case. Country B is aggressive, but not as aggressive as when they don't have oil. Delta should be negative. When one country has oil, but then I move this country away from the border, I should get less conflict, because the aggressor becomes less aggressive. Eta should also be negative. Again, when the oil that is closer to the border moves away from the border, the country that is typically the aggressor becomes less aggressive, and so you should see less conflict. But, on the other hand, omega should be positive. When I make the typical country, the typical aggressor more secure, by moving their oil away from the border, I should get more conflict. Now, the most important thing I have to say about this paper is where is identification coming from? And here is where the country fixed effects are completely crucial. Okay? So because I have country fixed effects, here is the kind of question I'm asking. Let's take a country. This country could be fighting a lot or very little with others, on average. But the question I'm asking, because of the country fixed effects, the kind of questions I'm asking are these. Does this country tend to fight more with its neighbors that have oil than with neighbors that don't have oil? Contingent on a bunch of neighbors who have oil, does this country fight more with those neighbors whose oil is near the border or those neighbors whose oil is away from the border? Or similarly, if this country has oil, does this country fight more with its neighbors whose border is near its oil than to its neighbors whose border is away from its oil? Okay? This is going to be identification. Okay? And I would argue that this is a much more closer to give us confidence that causality is achieved than if I just run a cross-country correlation. Okay, so these are my, the controls. People always want to know what the controls are, so I will actually read them to you. So this is, remember, this is a country pair level regression. So controls are specified at the country pair level. So the minimum and the maximum between the two countries in the pair of land area, population, GDP per capita, democracy score, military capabilities, and in addition, a dummy variable for whether there is a civil war going on in one country, whether there's a civil war going on in both countries, what is the level of bilateral trade between the two countries, whether the two countries are in a defensive pact, whether one country is an OPEC member, whether both are OPEC members, and also how long has it just been since these two countries have been fighting with each other. Okay, so here are my results. I show you here three specifications. The first column, I don't have country fixed effects. I don't have additional controls. I don't have my controls. Second specification, I have country fixed effects, but no controls. The last one, which I will focus on, as I have both country fixed effects and controls. What do I get? I get a pattern of coefficients that is completely in line with the theory. Okay, so if you get one country as oil, you get more conflict than when neither country is oil. But as I move away the oil from the border, the conflict goes down. If both countries have oil, I get more conflict than when neither one, but less than only one has it. But if I move the closest oil away from the border, the conflict goes down. But if I move the farthest oil away from the border, conflict goes up. This last one is insignificant, but overall the pattern of coefficients is completely in line with the theory. Okay, so far, qualitatively, it does look like it's really important to think about the geographical distribution of the oil to get at the effect of the oil on conflict. But of course, the most important question is quantitatively, how big is this? How important is this? How important is location? Okay? So with the last 5 minutes on this paper, and then I'm going to the other paper, I want to talk about the quantitative implications of these regression coefficients. So in particular, what I'm going to do, I'm going to fix all the controls at the average value in the sample, and then I'm going to compute the probability of conflict implied by these coefficients for a series of variations on the combination of these 5 variables. Okay, I'm going to think about a bunch of different combinations of whether one country is oil, both countries have oil, where is the oil, and ask how does the probability of conflict change quantitatively given these coefficients as I go through this specification, to these alternatives cases. Okay? So let me start again for the baseline. Remember, the baseline is that neither country is oil. Given my regression coefficient, so this is basically means that in this regression here, I'm putting both 1 and both to 0, all right? And then I compute the probability of conflict given this, given that coefficient. So the baseline, in my sample, when neither country is oil and all the controls take the average value in the sample, the typical country pair fight 3% of the time. Okay? Now the next question is, okay, let's see what happens when I put oil in one of the two countries. But, of course, the whole point here is that you also need to say where is the oil. So here, in this first exercise, I'm going to put the oil as far away from the border as I observe in the sample. So I take the maximum distance that I see in the sample and I put the oil there. So this is oil in one country, but it's really far from the borders. What happens to the likelihood of conflict? Well, it goes up, as the theory says. The theory says it should go up. But as you can see, it doesn't go up all that much. It's not that bad. If you find the oil very far from the border, it's not that bad. It's a little bit bad, but not that bad. Okay? But of course, I have a negative coefficient on the distance. So if I move the oil towards the border, I should get more conflict. How much more conflict? So let's do that. Let's move the oil towards the border. And I get, if I go all the way to the border, my probability of conflict quadruples compared to the baseline. Okay? So oil far away from the border is like it's not there, almost. Oil on the border, you get 4 times as much conflict as with no oil. It's a huge effect. It really matters where the oil is. Then I can do the same for the case where both countries have oil. Again, I need to say where the oil is. So here, in this case, I'm going to put the oil exactly equidistant from the border. Perfect symmetry between the two countries. Perfect symmetry. And on top of that, the particular location is going to be the halfway point between the border and the maximum distance that you observe in the sample. Okay? Once again, as predicted by the theory, I get more conflict. Okay? So oil brings to more conflict. But in this very asymmetric case, this very symmetric case, not that much more conflict. Okay? Basically, country B's incentive to attack country A kind of almost cancel out with the fear of losing their own oil. And the same is true for country A, and so the effect is not that big. But if I create a very unequal distribution, whereby country B is very secure because the oil is very far away from the border, but country A is very insecure because the oil is on the border, my likelihood of conflict goes up by a factor of 3 compared to the baseline case where neither country is conflict. So once again, location is essential. So what's the conclusion? The conclusion is that, thinking about the geographical distribution of the oil gives you a handle on a particular mechanism, which is this mechanism of countries trying to grab each other's oil. And if you do that, if you're willing to do that and go out and measure these distances, you actually learn that the concerns expressed by international relations scholars and political scientists, that actually this kind of resource grab wars are significant, that concern seems to be justified. It is there. And it's also potentially quantitatively significant. So based on this, coming back to the original question, you find oil, good news, bad news, some degree of concerns, you can be a little bit scary. You can be a little bit scared, especially if the oil is close to the border. Okay, that's one. Now let me move to my other thing. Complete change of setting and outcome. I'm going to focus on corruption now, but you'll see in a minute, or in 5 minutes, that geography is still going to play a major role in thinking about this, especially about identification. So, of course, many people have said one problem when you find oil or other natural resources is that there's going to be much more corruption, and politicians will get more bribes, or which is what was going to be the focus on this paper, they will steal more public money. So this paper is going to focus on this second thing, which is more technically, more appropriately described as embezzlement. Okay, so oil resources generate revenues coming into the government budget, which are controlled by politicians. A lot of people think that this thing of the money coming into the government budget creates massive incentives and opportunities for embezzlement by politicians. Now, of course, measuring corruption is very hard. I mean, you don't. It's very hard to actually measure, to pick up how much politicians are stealing. In fact, in the literature, almost all work on corruption, empirical work, is based on going around and ask people how many bribes did you pay last year, which you might have a lot of concerns about studies based on something like that. Now, here I'm going to pursue a slightly different strategy, which is not problem-free, but it's an alternative, at least, which is something that we call missing money. And the idea is the following. Suppose that you know that there has been a resource windfall, a fiscal windfall coming from natural resources, that you can actually quantify. You know how much money is coming into the government. Okay, suppose you can quantify it. And suppose also that you have some mechanism that force the policymakers who are in charge of these funds to account on how these funds were spent. So, you make them tell you, I spent this much on hospitals, this much on schools, this much on roads. And then suppose, this is the third step in the chain, and I'll go through this chain later. Suppose then that you also have the ability to go out and measure actual outcomes. Not how much the politicians say they spent, but how much actually gets built. How many hospitals, how many schools, how many roads, how many welfare checks were sent out. Then you can compare. You know how much was spent, or how much a politician said they spent, and you also can go out and measure the outcomes. And you might find yourself in a situation where, yes, the actual on-the-ground outcomes move around in a way that is consistent with the reported spending, or it may be that they don't. If they don't, then there is the situation which we call missing money. Now, if money is missing, one possible explanation, and I would argue, probably, certainly me, the first one I would think of is embezzlement, that the money was stolen. That's not all we do. We do a little bit more than that, which I'll show you, but this is the main idea. Okay? So try to measure three things. Measure how much revenue is coming in. Look at how the revenues is accounted for in terms of the formal budget process, and then look at real outcomes on the ground to see if they match the description that the government makes of this. Now, to do this, you need an exogenous source of variation in the fiscal revenues from natural resources. And you also need to be able to kind of trace this money as it gets into the budget from the revenue side and now is accounted on the expenditure side. Now, the one setting where you can kind of do this, and where we try to do this, is the setting of Brazilian municipalities. Okay, so this paper is going to be about natural resource windfalls, specifically fiscal windfalls, in Brazilian municipalities. Now, to see how this works, let me go, and also to start bringing in geography, let me go to a very stylized map of the Brazilian coastline. So the focus is going to be on offshore oil, and I'll tell you why later. It will become clear later. How much time do we have left?
Say 10 minutes or so?
10 minutes. But we started at 12:30, didn't we? Okay. So you're cutting my time.
Let's say 10 Mexican minutes. Okay? So 20.
Okay. So this is a very stylized map of the Brazilian coastline. So this thick line here is the coastline. So this big empty space is the ocean. Okay, this is the ocean. And then I have three municipalities, A, B, and C. This horizontal line are the municipal boundaries onshore. Okay? Now, the Brazilian setting is interesting because somewhere out there in the sea, there are oil fields. There are offshore oil fields, which are kind of spread around. And this is, by the way, these distances are big. You measure them in several dozens of miles, 20, 30, 40, 50 miles. Now, the Brazilian oil legislation is very interesting. It's still very interesting, but it's changing now. But at the time of our data, has the following characteristics: that whenever oil is pumped out of these oil fields, and by the way, the amount pumped out is roughly proportional to the size of the oil field. The amount pumped out is subject to a royalty payment to municipalities. Okay, 3%. 3% of the gross output of the oil fields has to go to municipalities. Now, how is this allocated across municipalities? There are all sorts of rules. The paper, by the way, I didn't know the co-author. On this paper, my co-author is Guy Michaels, my colleague at LACEA. The paper is like a 15-page appendix on all the rules for royalty allocation. But for our purposes, one part of the royalty allocation is based exclusively on a purely geographic criterion. This is where geography coming in. And in particular, it says this, that a certain percentage of the royalty pot or cake that should go to municipalities goes to municipalities that are facing, this is actually the word in the legislation, facing the oil fields. And in particular, what do you have to do? You have to project the municipal boundaries far out on the continental shelf. And then what you want to do if you're a mayor, you want to hope that the projection of your municipal boundaries out capture as much as possible of an oil field. And then the royalty you get are proportional to how much you manage to capture with this projection. So this is the graphical representation of this. So here, so I made my life very easy here because I drew municipal boundaries that are perpendicular to the coastline. You can imagine the complexity when the coast is kind of fractal. But I'm not going to give you all the details about that. So I'm just projecting the boundaries on the continental shelf. And now here you see it's a total lottery. It's a total lottery. You know, country A, they won the lottery. Their municipal boundaries just happen to capture a big chunk of the oil field. Country C won second prize, and these poor bastards in country B, they didn't get anything. Okay? So the royalty is allocated on the basis of this kind of fairly random ability of the municipal boundaries. And by the way, you know, here it sounds pretty crazy, but now think about a coast that goes from convex to concave all the time. And just think about just the pure sheer luck. You know, if you are in a very concave part of the coast, you're going to get nothing because your boundary will kind of meet very close to the coastline. If you are in a very in a very concave part of the coast, you're going to get a lot of oil because your boundaries are going out. Anyway, so what's the idea here? The idea here is that we have an exogenous fiscal windfall, okay, in the form of royalty, which is based on how much you capture. So we are going to ask the question for a bunch of outcomes: how do outcome on land vary with the amount of oil that is attributable to you because of the geographic component of the royalty allocation formula? Okay, and we make two claims about this. The first claim is that this is likely to be causal, okay, because you know, the only difference between municipality A, B, and C is just that the boundaries happen to go in different directions and capture the oil in different ways. So that's coming, and by the way, we back this up in the paper by showing that before the oil discoveries in 1970, there were no differences, no detectable differences in any socioeconomic outcomes in this municipality. All the differences came after the oil discoveries. The second point, which is equally important, is that any effect on outcomes on land, any causal effect, they come exclusively through the fiscal side, through the fiscal windfall. They come exclusively because of this royalty that you get. And the basic way to argue this is that was already hinted at, there is no market interaction between these locations and these locations. Country A does not interact with this oil platform more than country B. They are far out at sea. That's why using offshore oil is very important here, because if it was onshore oil, you would worry that there would be market interactions between the oil installations and the local economy. And by the way, we also have some empirical evidence in the paper that sort of backs up that there is no direct effect. And so all the effects are through the fiscal windfalls. Okay? So now we have an experiment where basically randomly injecting oil-related revenues, we call them petroreales in the paper, we are randomly injecting oil revenues across municipalities that are otherwise very similar, all on the coast, and asking how things change. Okay? So I'm not going to take you through the 15 tables in the paper. I'm just going to tell you what the tables show. So the first thing we do, basically three things, and I'm basically going over again the three steps I talked about. We do three things. We first check that these red areas predict municipal revenues. We know it has to be the case because the law says they must, but you know, Lant already, 1 hour ago, Lant explained that there is a big difference between the jure and the facto, so it's important to check that indeed you see the revenues going up when the red areas are big. So we do that and we find very nice, it's very clear that in the budget there is big spikes in the budget when you get this oil. So that's number one. So part one of our strategy is check. The money is coming in. We see coming in, we know how much it is because, in fact, we can quantify for every dollar of oil pumped out that belongs to you, how much do your revenues go up? Okay, the answer is 3 cents. Okay, for every dollar pumped out from the oil field, 3 cents come to you. Okay, so we know that. Then we say, okay, very good. We see the money coming in. Let's look at the expenditure side of the budget. Okay, we're talking about a piece of paper here, the budget, what the government says. And the budget is broken down by category of spending: education, health, infrastructure, social housing, sanitation, welfare checks, welfare payment, roads, transportation. There is all these categories. And so for each of these categories, we can ask the question, how do the reported spending on these categories change as you get this money coming in? And it's beautiful. When you look at this, you see a very responsive, careful, conscientious government that accounts for every real. Because all of these items go up. For every dollar, 20 more cents of social housing, 10 more cents of education, 10 more cents of health spending, 5 more cents of welfare checks to families. Roads, you can actually quantify by how much the spending and all these things is reported to go up. So number 2, checks. The government very kindly tells us what are they doing with the money. And then we go to step 3. We set aside all official budget data, and we go to survey data or census data, which measures a very large number of outcomes, real, actual outcomes, that kind of match with the budget items that we see going up in the budget. And we look at something like about 25 real outcomes, okay? And as you can imagine, when you look at 25 real outcomes, you get many different, you don't get always the same outcome. So let me say the following. The vast majority, nothing happens. Okay, especially in the category which goes up the most, which is social housing and social infrastructure, things like sanitation and electricity provision and garbage collection. There, nothing happens. There is exactly the same, municipality A, after the oil, has exactly as much people living in favelas as municipality B, same poverty rate, also, welfare payments to families, nothing happens. There are actually some categories that worsen, okay, statistics. When you find 25 outcomes, I guess you're going to find a couple that worsen. Now, there is a little bit of action, so it's not all bleak. There is a little bit of action on education and health. But, we have this, there is a potential for making back-of-the-envelope calculations because we know how much money is coming in and how much of that money the government reports they're spending. So if you're willing to be very heroic, and it's admitted it's very heroic calculations, you can actually say, these 2 outcomes where something moves, are they commensurate to the spending that should be associated to these things? And our back-of-the-envelope calculations suggest that they're not commensurate. In other words, that teachers are incredibly expensive based on this calculation. Okay? So that's the missing money result. Okay? So that's how we end up saying, look, here there is a mismatch between the money coming in and the actual outcomes on the ground. Money seems to be missing. So our first, I'm Italian, so the first thing I want to say is, I know what's happening to this money. But of course, you might say, this is not as good as, catching the mayor with a bag full of money walking into a bank in Miami. Okay, so obviously, it's an alternative to asking people, are you paying bribes? But of course, it's basically a residual explanation. So we try to do just one thing. It also has a lot of problems, but we just do one thing. We said, okay, let's do just something, that will never get published. In fact, the first thing that the editor told us to take out of the paper was this, but we still like it, so I'll tell you about it. Is this? We said, let's just do this. Let's go through the archive of the Brazilian news agency and do the following recursive Google search. For each municipality, make a search for the name of the municipality, the Portuguese word for mayor, and the Portuguese word for embezzlement. Okay, and do it for each municipality. Okay, so for some municipality, you get a bunch of hits, i.e. there are stories in the media about embezzlement in that municipality with the word mayor in the story, and some municipalities don't get any hits. So then let's build a dummy variable that takes a value of 1 when you find a story or more, and the value of 0 when you don't find any story. Okay, so this is a linear probability for whether the municipality comes up in a story for embezzlement with the word mayor in it versus not. And then they say, well, we have this measure of oil at the municipality level, let's just regress it. Okay, just regress it on this. And the first result was kind of a bit ambiguous. So the first thing we did, which is the thing that economists always do, is to run this outcome on oil per capita. Okay, how much oil the municipalities have per capita. And we get a positive coefficient. So oil per capita predicts more stories on embezzlement in municipalities, but it's not statistically significant. This is under error. So it's not statistically significant. So we said, well, this is not that conclusive. But then we thought about it for a second and said, wait a second, why are we doing per capita? When the mayor thinks, should I steal this money or not, it shouldn't matter how much money per capita I'm stealing. What should matter is how much money I'm stealing. In other words, what really matters is oil per mayor, and not oil per person. And that is massively significant. Okay? Again, you can criticize this in many different ways. I don't want to overstate it, but between the missing money part and this bit, and by the way, if you do this on federal investigations with the same search, so federal investigation, Padilla work for mayor, and embezzlement, you get the same outcome. That's the same thing. Okay, so bottom line, once again, the geographical distribution of oil, admittedly with the help of some pretty crazy legislation, allows you, in this case once again, to make statements that I think are much closer to causal statement that is typical found in this literature. Now we are, and by the way, also, like for the corruption case, once you do this kind of more aggressive search for a causal mechanism, once again you end up siding with people who say, when a country finds oil, okay? So when that, it may not be necessarily such great news. Again, I don't want to give you an inflated impression of my own contribution to the literature. There are other people who also are doing great work on causal identification. So again, when I talk about phase 3, in this work on resource windfall and outcomes, I'm far from the only one who's working on this. There are many other people who are working very good papers, including papers using geographical distribution of the natural resources. There are very good papers on Colombia and oil location in Colombia, papers with gold mines and distance from the gold mines. So there is a whole bunch of stuff. But I think the thing I wanted to try to convey is that there is progress. I think we are managing to move away from the cross-country correlation in the case study. And one particular way that is very productive, I think it has been for me, is to use the geographical distribution of the natural resources to get a causal mechanism. Okay, thank you very much.
Will you take questions? Will you take questions? If anybody has a question that cannot be posed in lunch time, over lunch, please do it. Go ahead. Who has a question? You're the chancellor.
And just going to talk loud. The question I have is, I would expect these effects, both in the case of Brazil, in the case of the war, to be very heterogeneous depending on the capabilities, the institutional capacities of the country. And which is an important prediction when we look at concrete cases. I guess you have looked at that. Would you have anything to say about it?
No, I think you are putting the finger on an area where I think we need to do a lot of work. It's incredibly important. I mean, I would never, nobody in his right mind thinks that, if Swedes find oil near the border with Norway, there's going to be a war between Norway and Sweden. So, it's clearly, nor that if they find oil, corrupt, Sweden will suddenly become a very corrupt country. So it's clear that there is massive heterogeneity. And I think, and by the way, and this is not just for the effect of natural resources. I mean, I think this is the question of development. There is some variable X that we haven't pinned down yet. Now, it's very tempting, but I think way too superficial and facile to say, it's just institutions. Sweden has good institutions.
adequately by the institutions. I think that's a ridiculous way of thinking about it, because of course, even some of the work that I didn't talk about, but I have another paper on, for example, political institutions, and where I showed very clearly, of course it's very clear, it's very clear to me that natural resource windfalls also change the location of a country on the autocracy democracy spectrum. So I think it's palpable that institutions there's a feedback effect for institutions, and so my view is that there is still some kind of variable X which affects both institutions and the way countries respond to various types of shocks, including resource windfalls. I think we know very little about what X is. I think we should all be working on X.
Yeah, do you analyze how changes in the price of oil affect the probability of conflict? I mean, price of oil being endogenous too, right?
Yeah, obviously, yeah. That's initially we thought we would do something with it. I think we moved away from it mainly for the reasons that the oil price is very endogenous to conflict. So imagine that there is conflict. Conflict erupts between two countries that have oil. Well, we already know what's going to happen to the price of oil. So there's an endogeneity issue, the price of oil, which I think is very hard to deal with. So far we've been trying to stay away from it.
Aloiso has a question.
Yes, a small point. In the case of Brazil, for example, when you get this more money in this municipality, there are lots of migration. So the fact that you don't get...
No, we looked at that.
There's no migration?
It's an amazing thing. That's one of the amazing things. We have looked at population trends as a function of... So one of the outcomes... one of the outcomes we looked at in terms of the ability of the red areas to predict population growth, and we didn't find anything. So people are not flocking systematically to the municipality with big red areas.
Well, I don't know. It surprised me. I'm Brazilian, so I read all the time the newspaper that
it surprised us
these populations of this, they flock and they create lots of new slums. So it's, anyhow.
Yeah, I mean, obviously that was the first thing we worried about, as you can imagine. And so we ran that regression.
Predict theoretically, right?
Sorry?
That's what you predict theoretically, to moving to Tibuto equilibrium or something like that, right? You're moving towards the area where to be more resource.
Yeah, we didn't find any evidence for that. And actually, we interpret that as sort of supporting the view that these oil windfalls have not been that beneficial to the population, because obviously, if we don't see people moving in, it doesn't seem to be that advantageous.
Well, if there's no more questions, thank you very much, Francesco. And thank you very much to everybody.